right, folks, just a nice and quick one today, going over the second example from the 7.3 lesson. So our second example, we're looking to evaluate the sine of 2 theta. If we know about the tangent of theta is equal to negative 4 over 3, and theta has to be in between 3 pi over 2 and 2 pi. So let's start with this third clue right here. If theta is in between 3 pi over 2 and 2 pi, well, 3 pi over 2, I know that's 3/4 of the way around my circle. 2 pi, I know that's the full way around my circle. So that means what I'm working with here has to be in quadrant, and let's draw that a little bit nicer, has to be in quadrant 4. All right, here's my terminal arm. There is my theta. Now, if that's true, then the tangent of theta, if that equals negative 4 over 3, remember, that's just a ratio. So if we're working with negative 4 over 3, well, the tangent of theta, I also know that equals the ratio of my opposite to adjacent side. All right, so my opposite side is 4, my adjacent side is 3 units in length, and one of them has to be negative. Because I'm here in quadrant 4, I know my vertical component has to be negative, right? So and I'll draw that in a slightly different color there. There we are. I know my vertical component right here has to be negative. My vertical component, that is my sine component. So I'm working here, my sine, that's the opposite side, so negative 4. All right, my horizontal component then is 3 units in length. My radius is equal to, I know, my horizontal component, and that is 3 squared, plus my vertical component, that's negative 4 squared. That's my radius squared. Okay, so I can use that. You can pause the video there if you want and throw it up when you finish solving it. My radius should equal 5. If you're familiar with Pythagorean triples, 3, 4, 5, that is the simplest Pythagorean triple. Now, that's all great. That can lead us off to finding, if we so desire, the sine of theta and the cosine of theta, right? Where the sine of theta, that's my opposite over hypotenuse, and that is negative 4 over 5. My cosine of theta, that's the adjacent side over the hypotenuse. I'm working with 3 over 5. Okay, that's great. I still need to, though, the goal of this question, I need to evaluate the sine of 2 theta. Well, the sine of 2 theta is going to be a little bit tricky. I could use my calculator, take the inverse of the inverse sine of this equation, or the inverse cosine of this, and find the angular value for theta, and then I could evaluate 2 times that. But I should be able to solve this without a calculator. So let's go take a look for some shortcuts. I'm working with the sine of 2 theta. All right, let's get up here, up to the work we've done. The sine of 2x, that equals 2 times the sine of x times the cosine of x. All right, so I'm going to copy that, bring it down to where we're working over here. And we'll be relying on that equation. There it is. Oops, right here. Perfect. So the sine of 2 theta, well, that's equal to 2 times the sine of theta times the cosine of theta. Well, luckily, I know the cosine of theta, and I know the sine of theta. So what I'm working with here is simply 2 times the sine of theta, that's negative 4 over 5, times the cosine of theta, that's 3 over 5. And simplifying this fraction is the last step we need. So we're working with 2 times negative 4 over 3, and that is negative 24 over 5 times 5, that's 25. So our final answer, sine of 2 theta, that was what the question was asking us to solve, is equal to negative 24 over 25. Well done, folks.